Hello, and welcome to the Gallery of Graph. And now, here's your host, Will.
Welcome to today's video. Today we're going to be looking at sketching Quartics. And so Quartics come in two forms. We have our quote-unquote turning point form here, which is y equals a bracket x minus h bracket to the power of 4 plus k. Okay. And then we also have our factorized form, which is going to be when your quartic is laid out in some factors. So I've just got y equals x minus alpha times by x minus beta times by x minus gamma times by x minus delta. And of course, alpha, beta, gamma, and delta are just placeholders for any variables that you could want to put in there. Okay, so looking at our turning point form, well, of course, we have A, and just like in every other type of graph, A stands for dilation factor there. We then have the horizontal translation factor, which is H.
Put it in H!
Horizontal translation. We have our vertical translation here, which we represent with the letter K. Okay? And so with all of that, let's jump in to see how these affect the shape of our graph.
Like and subscribe!
We're over in Desmos, and we have our beautiful basic y equals x to the 4 graph. And if we compare this to a quadratic, a x squared graph, we can see that it has a fatter bottom.
Fatty bun batty.
It's quicker, so its y values are closer to the y-axis versus a quadratic where they sort of, it's a bit more parabolized, I guess you could say. It's a little bit more rounded off. So anyway, we've got ourselves a quartic here, and the quartic is just our basic one. Now, if we change our dilation factor to be a value that is greater than 2, what we get is we get a dilation towards the y-axis where everything's stretched out a bit. And that is, of course, well, we take x equals 1 here. Well, 1 to the power of 4 is still 1. It's just 1 times 1 times 1 times 1. But if we have a 2 out the front, then that 1 times 1 times 1 times 1 times by 2 gives us 2. And of course, with a even power, we're always going to get an even answer despite having a negative input. So negative 1 to the power of 4 is still 1, positive 1 that is. And then if we times that by 2, we get positive 2, just like for our dilated graph there. And just like with a quadratic, if the dilation factor is less than 1, well, then we get a fat boy graph like that.
He's a little bit of a porker. He's a fatty bun batty.
Where the value is put to the power of 4 and then halved in this case, or made smaller by multiplying it by a number less than 1. So that's how dilations work there. The next thing, of course, is we can have a reflection. And the reflection is going to give us a sad quartic.
Why are you always in such a bad mood?
I have a nail in my anus.
Oh.
Like so. So we simply putting our value in, putting it to the power of 4, and then slapping a negative on the front of it. And so that's why we get a sad graph here. Moving on to our horizontal translations. Well, just like in every other graph we've looked at in our Gallery of Graphs series, what we have is when we have a positive h value, the graph is going to move in the negative direction for x, which is to the left. To the left, to the left. And then when we have a negative h value, it moves to the right. Because, of course, we are solving the null factor to get the x-intercept there. When we have a positive value, it goes up. And when we have a negative value, it goes down. And so that's all we really need to know for that. And so now that we've seen how all of the translations and transformations can work, let's jump into a question and see how we can graph one of these.
Well, what about that tattoo on your chest? Doesn't it say die, but die?
No, that's German for the.
Will's Tutoring, where you can get a free trial session and 3 free cancellations per term for sickness and family emergency.
The.
No one who speaks German could be an evil man.
Parole granted.
Okay, so looking at our first example question here, guys, we are looking at sketching this quartic in turning point form. And what we can see here is we have a dilation of factor 3. We have a horizontal translation of 2 left, and we also have a vertical translation of 1 down here. And so with that information, we can say the turning point, we'll say is TP, not to be confused with toilet paper. Well, that's going to be 2 to the left, which would be -2, and then also 1 down, so -1. That's going to be our turning point there, or TP for short. Then with that information, we are going to have something along the lines of, well, -2, -1 will be in that third quadrant. So we're going to get something along the lines of that, which means that we'd need an x and a y intercept there. I know it looks like it's going through the 0, but that's just because I drew it there. So we need to find our x and y intercepts. And so what we would need to do here, of course, is we are going to start off with finding the x-intercept. What does y equal the x-intercept, everybody? Of course, it is 0. And so therefore, we're going to get 0 equals 3, bracket, x plus 2, bracket, to the 4 minus 1. And using our reverse BODMAS skills, please check out the video in the description below if you don't know what I'm talking about. But what we are going to do first and foremost is we are going to add 1 to both sides to get rid of that minus 1 there. And so with that, we then get 0 plus 1. A bit of a hard question. I think that might be 1, which is equal to 3, bracket, x plus 2, bracket, to the power of 4. We then have this times out the front, this 3, so we're going to have to divide by 3 on both sides, and that's going to give us an Irishman's second favorite fraction, which is a turd. The next thing we need to do after getting our 1/3 equals x plus 2 to the power of 4 is we need to fourth root this bad. So for root here. And what we are going to get is we are going to get we're going to get plus or minus, remember, because when we have even powers, they have 2 solutions. We're going to get plus or minus the fourth root of a turd there, or an Irishman's second favorite fraction. And that's going to be equal to x plus 2. From here, we can then subtract 2 from both sides. And we're going to get x equals -2 plus minus the fourth root of a third, which according to our Surd's laws becomes 4 root 1 over 4 root 3. Sorry, I'll make that fourth root. Let's do 4 root, which then goes to become -2 plus minus 1 over the fourth root of 3 there, because the fourth root of 1 is 1. So then that is going to give us 2 solutions there on the calculator. I'm just going to have a little bit of a faff around. So when we have -2 plus 1 over the fourth root of 3, we get -0.1. We get -1.24. And then if we have the minus variance, -2 minus 1 over fourth root 3, we get essentially -2.76 roughly. So those are our 2 x-intercepts there. Now we got to go ahead and find our y-intercept. So finding the y-intercept, of course, y-int, what does x equal at the y-intercept? It, of course, is 0. And so what does this mean? It means that we're going to get y equals 3, bracket, 0 plus 2 to the 4 minus 1. Okay, so that means we've got y equals 3, bracket, 0 plus 2. Oh, that's a bit of a hard question. I think that might be 2 to the 4 minus 1. 2 to the 4, well, if you didn't know, here's a bit of a fun fact for you. 2 to the 4 is equal to 4 to the 2, which is 16. Coincidence? I think so. And in this case, we have y equals 3 times 16 minus 1. 3 times 16 is going to be 16. 32. 48. So we're looking at y equals 48 minus 1. Y equals 47. Okay, so now we have everything we need here. We've got our toilet paper up here, the turning point. We have our x-intercepts of -2 plus or minus 1 over the fourth root of 3. And then we also have our y-intercept of 47, or in coordinate form, 0, 47. So now we can go ahead and graph our graph. I'm going to leave a little bit more on the negative side here, and then quite a lot on the y positive side, because we've got to go all the way up to 47. So this might be a little bit of an artist's rendition here, because I'm not going to draw out 47 squares here. That might be a little bit over the top. Anyway, so I've got y and we've got x. And so our intercepts for the x are at, well, let's do the turning point first. Turning point is at -2, -1. -2, -1, that's going to be right about there. And then we're looking at -1.24, which would be slightly above 1. And
hey guys, just going to interrupt the video for a second, but if you are enjoying it, then please consider supporting the channel. Old Willie's maths and memes don't put themselves together, I can tell you that. So if you would want to support my work, then please consider buying me a coffee or donating on PayPal. Additionally, I do have a Patreon where I'm going to be uploading chapter-specific solutions to the problems out of a popular textbook series that rhymes with Lanebridge, if you're in Australia. And so if you want to get that, sign up for the Patreon. And finally, if you would like more bang for your buck, then why not hire The Real Deal by contacting me on Facebook or Instagram or X or YouTube or all of the social medias and organizing a free trial session from Will's Tutoring, where you can also get 3 free cancellations per term for sickness and family emergencies. Anyway, like and subscribe to the video. That's the end of the plug. Bye!
-2.76, which is going to be slightly below 3. And so our graph, our Quartic graph should, oh, and also we've got something here. It's y equals 47 or 0, 47. This one's obviously not the scale, but you get the idea. And so we're then going to put our y value, let's say like this is 47 here. And then when we're graphing it, we're going to go like that. And I'll just make that nice and fat so it's a bit obscured. But yes, with our quartic as opposed to a quadratic, we need to make sure that that bottom is a bit flatter than usual. We have a fat boy quadratic opposed to a thin boy. So our first intercept all the way on the left there is going to be -2 minus 1 over the 4th root of 3, 0. This rolls right off the tongue, doesn't it? And then we also have -2 plus 1 over the 4th root of 3, 0. And then finally, we have all the way up here 0.47. And then that is how you sketch a quartic in turning point form. And so now we're going to look at sketching a graph in factorized form.
Well, here we are at the Brad Goodman lecture.
We know, Dad.
I just thought I'd remind everybody
The Will's Tutoring is offering a free trial session and 3 free cancellations per term for sickness and family emergencies.
What an odd thing to say.
Okay, and so now we're going to be looking at quartics in a factorized form. And because they're in factorized form and it's a quartic, there is 4 different factors that we could have and 4 potential different outcomes we can have with these factors. Of course, we can have 4 different factors. We could have 3 factors where one of them is squared, 2 factors where both are squared, or 2 factors where one is a single factor and the other one is cubic in nature. And so with that, we can now have a look at what they look like on Desmos here. So now that we're on Desmos, let's have a look at what these look like. So first of all, this red graph here is our normal y equals x to the power of 4. So we're going to say goodbye to him and say hello to if we had 4 different individual factors. Now I've just used x equals -1, x plus 1, -2, and plus 2 here. And as we can see, our intercepts line up with those values. So -2, -1, 1, and 2 here. Great. So that's what it looks like when we have a single factor. So just like in cubic factorized form from the previous video, link in the description, by the way, if you want to know how to draw a cubic. Well, you can see, of course, that we have all of our intercepts related to those. Now, when we transition over to one of those terms being squared, right, specifically x plus 1, we can see that its intercept becomes a turning point intercept. What does that mean? It means that our graph is coming down, 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 down. It just does a little bit of a smoochie, just a little bit of a kiss into the x-intercept, goes back up, and then our other 2 values, x minus 1 and x minus 2, are just regular intercepts where the graph passes through and are not a turning point. Well, I think you can see where this is going. So when we've got the squared, we get a turning point. And so when they're both squared, we get 2 turning points. So x plus 1, x minus 1, well, both of these values have a turning point. So the graph comes down, does a little smoochy, and then it comes back up and goes back down, smooch again, and all the way up. Then, lucky last, what if we had a single factor in a cubic? Well, we get a single factor in a cubic. So our single factor is just a regular intercept that goes straight through. And our other one is like the point of inflection of a cubic, right? If we basically chop the graph off here at this turning point, we have essentially a cubic where the graph is becoming flatter. It's that point of inflection and keeps going up.
What are you waiting for? Do it!
Okay, so looking at the first type when we have 4 different factorized terms here, well, it's just going to be a case of solving for the intercepts, essentially. So we have, of course, the x-intercepts, where what does y equal every single time, guys? Of course, it's going to be 0. And so 0 is going to be equal to x minus 1, x plus 2, x minus 3, and also x plus 4 there. All right, and to solve for x, well, we need to, of course, make these equal to 0 according to the null factor law. So to make the first term there 0, what we're going to need to do is x is going to need to be 1, positive 1. And the second term, x is going to need to be equal to -2, positive 3, or of course, -4 there. And so therefore our x-intercept coordinates would be going left to right. It would be -4, 0. Then we also have -2, 0. Then we have 1, 0, and then 3, Great. Finding the y-intercept. What does x equal at the y-intercept every single time? Of course, it is 0. And so we can now say that y is going to be equal to 0 minus 1 times by 0 plus 2 times by 0 minus 3 times by 0 plus 4. And then a bunch of brain busters coming up. 0 minus 1 is going to be -1. 0 plus 2 is 0 minus 3 is -3. And then, of course, we have 0 plus 4, which is going to be 4. And because we have a negative and a negative in here, well, that's going to give us a positive times by 2 more positives. Our answer is going to be positive overall. So what is 1 times 2? It's 2. 2 times 3 is 6. And then finally, 6 times 4 is going to be 24 there. Or in coordinate form, that would be 0, 24. And so that's all we need to graph our graph here. So let's go ahead and do so. So we're going to need to have a slightly extra longer y-axis here. Let's pull that up. And then we're also going to put in a x-axis spanning from about -5 to 5. So 3, 4, 5. Great. And then let's go ahead and put these points in. So our first point is at -4, 0. -4, 0 is going to be there. We also have -2, 0 there. And then we have 1 and 3. The next thing we need to do, of course, is put in the y-intercept. And we're just going to go up by 1, 2, 3, 4, 5, 6, and say that this is 24 for the y and x-axis, yeah? And then we have that. I'm just going to extend the y-axis just a little bit here. So now, what we are doing, of course, is we are sketching this graph. And because these are regular intercepts that are not squared in any capacity, there's not going to be any turning points, and the graph is going to run straight through. So now, sketching our graph, of course, it's going to go through these intercepts because none of them are squared, and so none of them are turning points. So we're going to have to do a big old W here. It's going to hit a turning point before it hits that that y-intercept, and then we're going to get something like that. Probably should go down to the same value there. So just let's just pretend that never happened. It's a secret. Forget about it. Oh, get out of here. That's what our graph should look like, somewhat. So let's go ahead and put in our points. So we have -4, 0. We have -2, 0. We have 1, 0, and then we have 3, 0. And then our y-intercept all the way up here is going to be 0, 24. And then that is how you draw a quartic when you've got 4 individual factors there.
Like and subscribe.
The next type of graph we're going to have to be able to sketch is when we've got a turning point and then 2 single non-turning point intercepts there. And so, well, first things first, I'm a realist. Second things first, we need to, of course, find the x-intercepts. What does y equal those x-intercepts? Of course, it's going to be 0. And so we can therefore say that in this case, 0 is equal to x minus 1, bracket, x plus 2 squared, x minus 3. And with that in mind, guys, well, if we substitute 0 in for that and we use our null factor law to make this whole first term equal 0, x would need to equal 1. X would need to be minus 2. And let's just put a little asterisk there because it's a squared. And then we also have x would have to be 3. Okay, so then putting them in coordinate form in order, we're going to need -2, 0. We're going to put a little asterisk there because this is a turning point 1, because it's squared. We also have 1, 0, and then we have 3. All right, and with that in mind, the next step in our in sketching this graph is to find the y-intercept. So at the y-int, what does x equal every single time? It's 0. And so we can therefore say that y equals 0 minus 1, 0 plus 2 squared, and then we also have 0 minus 3. So we've got y equals 0 minus 1 is going to be minus 1. 0 plus 2 is going to be 2 squared. Then we have minus 3 there. 2 squared is 4, so we then get, well, I'm just going to do it all at once. -1 times 4 is -4 times by -3 gives us positive 12 there. Or in coordinate form, that would be 0. Well, like so. And that is all we need to start graphing. So just remember that this -2, 0 is going to be a turning point because it is squared. So setting up axes here, just make a slightly longer y-axis there. And then we're also going to need to slap down x-axis. And so we've got y and we've got x. And our turning point is at -2, 0. So there's that. We've got 1 and we've got 3. And then we also have 1 at 12, which is going to be, well, I'll make it 2, 4, 6, 8, 12. 2, 4, 6, 8, 12. It's going to go there. And what we're going to do is we're going to come down. We're going to give that -2 a little smoochy there. We're going to come up, do a bit of a turning point before we come through that y-axis, back down, and something like that. Now, I'm not exactly sure where the turning points would be. And that's a different topic, which we would have to learn about, called derivation or derivatives, calculus. And that's going to be coming up in the near future. Anyway, so we've got to mark our points now. So we've got -2, 0. That's our turning point 1. 0, 12 here. And then we also have 1, 0, and also 3 here. And then that is how we sketch a quartic when there is a single squared term.
Tutoring? Will's tutoring?
I'd better call Dr. Foster.
It's Dr. Foster here.
Will's tutoring, where you can get a free trial session and 3 free cancellations per term for sickness and family emergencies?
You're sure? No. I'll come right over.
and may God have mercy on us all.
Okay, and now looking at another situation we might find ourselves in, we have two squared terms here. We have y equals x minus 1 and x plus 2. Okay, so in this scenario, well, we need to first and foremost find our x-intercepts. So what does y equal at the x-intercepts? It's going to be 0. And so therefore we get 0 is equal to x minus 1 squared, x plus 2 squared. And we can null factor all this by, trying to find the value of x minus 1 equals 0. And so that means that x would have to equal 1, or the other one, it would be negative 2 there. And so writing these out in coordinate form left to right, we'd have negative 2 comma 0. We would also have 1 comma 0. And just for the sake of due diligence, let's put some asterisks there to show that they are in fact turning points. Then moving on to the y int, what does x equal at the y int? Everybody say it with me, it's 0. And so 0 is going to be equal to, y is going to be equal to 0 minus 1 squared. And then we've also got 0 plus 2 squared. Now, y is therefore going to be equal to negative 1 squared times 2 squared. Negative 1 squared is going to be equal to 1 times by 2 squared, which is 4. That's a pretty hard question, 1 times 4. I think that might be 4, or in coordinate form, that would be 0, 4. So that's all of that. We can now go ahead and graph this bad boy. We don't need a super mega axes here. We can just do something nice and small. So we're just going to go something like that and something like this. Great. Okay, so then we've got y and we've got x. Putting our turning point intercepts in, we have negative 2 and 1. So negative 2 and 1 there. And then y is going to be at 4. So 1, 2, 3, 4. That's going to be up there. And because this is offset, again, our Quartic is going to come in. It's going to give that a little smoochie. Hit a turning point before we go into our y-intercept. Do another little smoochie there and back out. And that's going to be our Quartic here. So let's put in our points. We've got negative 2 comma 0. We have 0, 4 for y. And then we have 1 comma 0. And that is how the cookie crumbles. Right. And so that is how we do a double turning point graph like that. The final type of graph that we're going to be looking at here, guys, is going to be when we have a cubed term and a regular term. So in this case, we have sketch y equals x minus 1. Bracket up there. We've got x minus 1 times by x plus 2 u. Okay, so, well, first things first. X int y equals 0, right? Because y equals 0 at the x-intercept. How many times? Every single time. That's the real answer. And what we're going to say is 0 is going to be equal to x minus 1 bracket x plus 2 cubed. And of course, we null factor law this, which means that we're going to get x equals 1 or negative 2. And so in coordinate form from left to right, that would be negative 2 comma 0. And we're going to put a little asterisk there because this is, of course, a cubic. And then we also have 1 comma 0. And so those are our x-intercepts. Next up, we have to find the y-intercept, where what does x equal? It equals 0. And so with that in mind, we can then say y equals 0 minus 1 times by 0 plus 2 cubed. That means that we're going to get negative 1 times by 2 cubed, which 2 cubed is going to be 8. So that's going to be negative 1 times by 8. Y equals negative 8 there. Okay, so now let's go ahead and sketch this bad boy, y-axis first. We're going to make a nice long y-axis there. And we're going to also go ahead and put up a slightly offset x-axis. Let's put it like here, I reckon. And then we can go ahead and graph this. So putting out our intercepts, now we have negative 2 comma 0. It's going to go right there. We also have 1, 0 there. And our negative 8, 1, 2, 3, 4, 5, 6, 7. Oops, going to go a little bit more. 8 there. Okay, cool. And so remember that negative 2 comma 0 is a cubed function. So that means that we're going to get like the point of inflection of a cubic there. So what does that mean? It means that it's going to look like this. I'll do it in red so that it sticks out a bit more. But it's going to go something like so. Going to come out, flatten out, and then go back to curving down. You see how that works? That's our like point of inflection, as if this was a cubic here. Then it continues to come down. It's going to hit a turning point, come back around, go through that y-intercept. And then, as the kids say, it's going to yeet off into existence like so. And that is going to be our Quartic there. So we've got y and x. Let's label our points. We have negative 2 comma 0. We have 0, negative 8. And then we also have 1 comma 0 here. And then that is how you draw a cubic where, sorry, a Quartic where one of the points is cubed and the other one is just a regular point. And so that's where we're going to leave it for today, guys. If you found this video helpful at all, please consider giving me a like and subscribe or a follow. I'm on all of the social medias. I'm on Facebook, Instagram, YouTube's, and Twitter, or X if you prefer. I also run a Patreon for Australian students. So if you use a textbook that's published by a company that rhymes with Cambridge, wink, nudge, nudge, I'm putting out answers on Patreon, so you can subscribe for that for as little as $1 a month. Anyway, so hope you've enjoyed the video. This is the end of the video, so bye.